first talk ever. So, what I want to do is take a selfie with everyone, because I don't want to ever forget this moment, you know? So, make a funny face, smile, want to get all the corners of the room. All right, cool, thank you. So my name is Thierry Damiba. I am new here at Quadrant. I just started a month ago. Today's actually my 1 month anniversary, and thank you. I'm a developer advocate at Quadrant. Previously, I was a data scientist for the Department of Homeland Security, and Quadrant has given me a nice 1 month gift where I get to announce our new offering to you, which is BM42, a sparse vector. And it's going to tie into hybrid search, which I will be talking about shortly. Oh, that's the wrong way. So, trivia. Does anyone know who these two people are?
Yes, Karen Spark-Jones.
Boom, and who are those people?
Famous professor in information retrieval who introduced the technique BM24.
Beautiful. BM24 as well as BM25, because you know they have to do it twice. No, I have so many gifts for you. Just see me backstage. A case full of cash. Don't worry about it. Just for you, with your name on it. So yeah, these are the people who actually created BM25, which is basically going to be the backbone of search in the world today. So I'm going to take you down memory lane. Follow me. So BM25 has been the gold standard in terms of search engines for a long time. Why has BM25 been the gold standard? Well, it's really good at searching large documents like the internet. So, because of the way that it handles IDF as well as term importance, when you're looking to search something which is a massive corpus as the internet is, companies like Google, Bing, etc. looked at models similar to BM25 because it was cheap, it was effective, and it got the job done, especially when you're talking about these very large data sets, large context, and long queries. But we're not in Kansas anymore, right? Things are changing. We know that it's the rise of the AI engineer, and as Atita mentioned, it's also the rise of RAG. And RAG differs from typical internet search in ways that we can imagine, right? If you're building a RAG application, it's, for example, going to be on your docs. It's not going to be on the entire internet. So you're going to have more context-specific information. Your queries are going to be shorter. In other words, we need a new tool to meet this new demand that we're seeing in these emergent AI applications. So what companies are currently doing, or developers I should say, is most of them use BM25 with a combination of some kind of embedding model. And Splade is another example of one alternative that people are using to BM25. What Splade does is, one of the drawbacks of BM25 is it's not great at knowing that words can have different meanings. So you see here that we have recovery, which can mean not only outcome, but also healing or perhaps health. And Splade is going to be able to dig that out for you. So it's good at that, but the problem with Splade is it's not very good with tokenization, it takes a long time to run, and it's fairly expensive. So if you don't care about those things, I guess you could use Splade. But if you do, we're introducing BM42. So BM42 is going to give you all the advantages of being able to search with IDF like BM25, but also you get the benefits of transformer search. So what do I mean when I say that? Transformer models have a lot of different outputs. Some of that output is used to generate text, some of it might be used to classify data. One of the outputs is this attention matrix. And the attention matrix, if you look in the bottom left, has this thing called the CLS token. And the CLS token has this feature that I like to think is pretty magical, where when we look in that first column, we can actually find the importance of these vectors throughout the entire document. And this is going to work with any transformer out of the box without any kind of training. So if you have a transformer model, you can use it with BM25 right out of the box, nothing special necessary. And then the other part of BM42 that kind of makes it kick is our BPE retokenization. So what that's going to do is it's going to merge the words that we split up back into words. Here's an example here with unbelievable, where we're breaking it into unbelieve and able. And if you look at the prefixes for believe and able, that's the way that we're going to be able to very easily tell, hey, this is actually part of a word. And then once we put those words together, we can do all kinds of NLP functions, such as removing stop words or punctuation, things like that. So, while BM42 is great, what we really want is to combine BM42 and hybrid search. And the reason we want to do that is because that's the way we're going to get the best of best worlds. We can use our sparse vectors for exact match, and then we can use our dense vectors for semantic match. You can also use a fusion model. So if you have some data, let's imagine, for example, you have a dress on Amazon, so that's an image, but there's also text that's going to describe maybe the brand of the dress or something like that. You could have a sparse vector for your exact match, a dense vector for your semantic match, an image model for the image, put them all together in a fusion model, and that's what's going to give you the best results because you're tackling those disparate, verticals that are inside of the data. So sparse vectors are better at that exact matching and dense vectors for that semantic matching. And here's a code example of how easy it is to get started with it. If you've used Quadrant before, you know how to create a client, or a collection, I should say. And all you need to do is just go in there, you tell us what dense vector you want to use. Here we're using Jinja as an example. You tell us what sparse vector you use. We're using BM42, and you're good to go. And obviously everyone wants to know, okay, so how well does this actually work? And for our benchmark, we use the core data set, which is 13 megabytes. It's about 500,000 documents. And you have 3 sample questions here that we pulled out just to show you what this looks like. It's short questions, right? Why can't I do my homework? Oh man, I wonder what the answer is to that. Can we get the, no, I don't have the answers, unfortunately, but I needed that one, so. But the general idea is here that we're gonna have these shorter documents, which are typical in RAG scenarios. And here you see, if we look at the precision at 10, BM25 is at 0.45 compared to BM42 at 0.49. So you're getting that increase in performance. But I do want to caveat this by saying this is just an example of where BM42 outperforms BM25. When you use these things in production, you're going to want to use both the sparse and the dense vector in combination to get the best performance. If you use either of them separately, you're not going to get as good performance. Oh, wrong way. Okay, cool. So that's all I have on BM42. Anybody know why we named it 42? Wait, what'd you say? But why that number? Boom, okay, yeah. Hitchhiker's Guide to the Galaxy. So we're big fans of that book over at Quadrant, and that's why we named it that. So thank you very much for your time tonight. Please join our Discord. Wait. Come on. Let me finish, then you can give me my flowers. Let me cook, come on. Okay. You can join our Discord. Our Discord is really awesome because we have people all the way up to our CEO, CTO in there answering questions. I saw someone yesterday ask a question and the CTO answered within like 5 minutes. So if you're looking to get free help or just join a cool community, get in our Discord. Wrong way again, sorry. And also, you can prototype for free using Quadrant. So you can start locally, which doesn't require any downloads. Go online, just check it out. We've got Docker as well. And we do have our cloud offering. So we have managed cloud as well as the hybrid cloud. And you can get started with a 1 gigabyte cluster that will be available to you for free forever, today. No credit card required. Just hop on the website, scan this code, get a free cluster, start building AI apps, change the world. You know how it goes. Thank you for your time tonight.